All right, welcome to the third and final video in this unit on yield monitors. In this third video, we're going to take a look at some possible errors that we're going to see with our yield monitoring system, as well as look at some maintenance, what to do before, after season. And then we'll kind of wrap up looking at some yield monitors for some different types of crops, as well as some of the things that we're starting to see coming down the line. So to jump right in, so far in this unit, we've talked about how the systems work, what needs to be done, how to calibrate it. So as we go forward, what are some potential errors or possible errors that we could see in this system? And what can we do to take care of it? So a lot of times the biggest errors that I have seen and what others in the industry have seen is improper calibration. And whether that was the didn't calibrate for that crop, didn't do the load calibration, so the grain flow sensor is not recording correctly or recording incorrect amounts of mass. Something's not right with the speed, like that shaft speed sensor. If it's being used, it was never measured distance off, or never took a moisture sample and calibrated that. So there's a lot of, as you saw earlier, there's a lot of calibrations, and if those calibrations aren't done, or if they're done improperly, that is where we see the most amount of errors that happen. So that's where that once again kind of hopes demonstrates to you why calibration is so important. So that's the biggest error. Another one is that we have seen improper installation of sensors. Not so bad now, because a lot of the sensors, like the grain flow sensor or the moisture sensor, they come from the factory built in, so we don't have to worry about cutting a hole in the side of the clean grain elevator to mount them so much anymore. Still have to do it from time to time, but that's where we've seen some improper installations. Here's a prime example. Saw this at a training session a while back. This is a clean grain elevator, and this was where the moisture sensor is supposed to be mounted. So the two holes here, the one on the left, the one that's circled in red, that's where the grain is going to be coming through from coming up the clean grain elevator. It's going to come through that hole, fall into the moisture sensor, and get recorded. And then it's augured back out into that five-sided hole there on the bottom right. Well, if you look really close, you can see on that larger hole, and that's where the arrow's pointing to, the hole wasn't cut exactly perfect where it needed to be. There's a little gap there. And that gap is just big enough that grains such as wheat, soybeans, even a few kernels of corn were known to pass through that hole. And so what happens is the grain is falling through down that backside before it even gets a chance to hit that sensor. And there were some other cases where those holes were even larger, where that holes weren't cut where they were supposed to be. So this kind of part of that improper installation. Other part is, and I don't have any photos to represent it, is how that clean grain or that grain flow sensor is mounted at the top of the clean grain elevator. If it's not installed properly, the grain's not going to hit it correctly like it's supposed to. So those have been the two biggest issues in terms of installation. Some other possible errors. The width of the header. The prime example I had, for years we used to have no-till soybeans. And so we weren't combining 8 rows. We would just combine the full width of the head as we went through the field. My dad had programmed it in as a 20-foot head. We noticed the first year we go through soybean fields and we get done, and the yield monitor would have us would record acres 2 to 3 to 5 acres more than what it's supposed to be. It was kind of puzzling and trying to figure it out. We actually, on a whim, just measured the width of the bean head. It's a 20-foot head, but the reality is the full swath that it could take was about 18 feet 6 inches. So we went back in and readjusted that in there, and then our acres are coming up a lot more accurately. With the incorrect acres, then our yield gets thrown off. So header width is one of those things where there's a potential error. Another one is changing that header height adjustment between crops. So once again, I said, different heads run at different heights. So if you pick it up a little bit to get through a waterway and it's programmed for the wrong head, it's going to stop recording. So want to make sure we have that right. Another big one is what's called potting. There is a video out there on the Blackboard. My good friend Adam Gittins down at HTS Ag has a nice little video where he kind of explains this potting. And what that is behind that impact plate, or that catcher's mitt there on the front. Behind that, it's a mass of wires, and that's what's recording that force. That is surrounded by a rubberized material. It's what's called potting. You want to check that potting on the flow sensor. It's something I can attest to from personal experience. Mice love to eat into that. So if that potting is worn out or cracked or missing or been chewed up and those wires are exposed, then it's not going to be recording the force correctly. So that's where we've seen an error in the past. Like I said, it was a personal experience that I went through. Another one is that impact plate, kind of that catcher's mitt there on the front on that flow sensor. Over time it just gets worn. In the video on Blackboard, Adam kind of goes and explains that as well. So you want to check and make sure that the impact plate is not worn too much. Another thing is, as I mentioned earlier, mice love to get in and chew on things. You also want to make sure that your cables and wires are intact, because mice have been known to chew into those. And it causes short circuits, and then things don't work, or the wire passes through a piece of metal and over time it wears against it and it shorts out. So you always want to make sure your cables and your wires are intact and they're not being pinched or broken. Along with those lines, you want to make sure your sensors are intact and working, so things like your elevator speed or your header height sensor. So make sure those are intact. So these are where most of the errors occur, is in the examples and what I presented here. So that's always kind of the first place to start on some of these. If things aren't working, check your cables, check your wires, check your potting on your float sensor. But, all right, moving into maintenance. Yield sensors, yield monitors, they're not cheap. And it's an investment, and you want to make sure that investment pays off in time. And by doing that, you want to make sure that system is around for some time. So you want to make sure you take great care in taking care of it. So here's some of the things that we want to think about. So I kind of start with the after harvest instead of the before, because it kind of flows a little bit better. So after harvest is over, you're ready to put that combine away. Take that grain flow sensor out. In most combines, it's not that hard. You climb up in the clean grain tank or at the top of the clean grain elevator, and usually it's a bolt or a wing nut, and you can pop that out, unplug it, take it and put it away and store it. Store it in a nice, dry, secured area, something where mice can't get to it and get into that potting. The other thing is that moisture sensor, as you saw in the earlier video series, where that moisture sensor has a little auger in there that augers the grain back out. You want to take that auger out, and in doing so, you're also going to make sure you get all the grain completely out of that moisture sensor. So once again, the mice can't chew on it or have a nice meal at your expense. So same thing there. Put that auger away, store it for the winter time. And then the third thing after harvest is take that display out of the cab. Displays are built rugged, and they have some pretty good temperature ranges that they can survive in. But like where I'm at here in Iowa, it's not uncommon in January where it gets -0, negative degrees for quite some days. It's not good for those displays. So you want to make sure you take those displays out, and once again keep those in a nice dry area. So that's what you should do after harvest. Then you get to the beginning of the harvest season. Here's some things you want to do. Before you put that grain flow sensor back in, you can check inside those elevator paddles, the clearance at the top. If you have too much of a gap in there, then the grain's not going to come up and hit that grain flow sensor in a correct manner. So you want to make sure you have the right amount of clearance. So all the systems typically say you want to have about 3/8 to 5/8 inch clearance. The best way to do it, what was told to me, was that's typically the size of your pinky finger. So if you can stick your pinky finger in there and it has room to wiggle, well, then you've got a gap in there. You need to adjust that elevator chain and paddles so you get the right amount of clearance. So 3/8, 5" to 5/8 of an inch, the pinky finger. The other thing is when you put that grain flow sensor in, once again, check that impact plate for wear. Also check that potting behind the plate. Things to note on that potting: if you see small little cracks in there, that's okay. But over time, that potting, like it's a rubberized material, over time it has a tendency to harden and become brittle. So if you start seeing some large cracks or missing pieces, or more importantly, exposed wires, and once again, watch that video that I have out there, then you need to have it replaced. I put repair there, but you can't just repair it, you need to replace it. Some other things to do before harvest: well, we took that auger out of the moisture sensor after harvest, so we need to stick it back in there. But before we do, we want to make sure everything inside that moisture sensor is nice and clean. As you saw in that previous video, there's a proximity switch up there. So while the auger is still out, have the system on, stick your hand up in there. And you should hear the motor sit there and turn, so that you know that proximity switch is good. Those have been known to eventually fade and wear out over time, so it's not uncommon that you have to replace that. But that would be a good time to check it. Otherwise, your moisture is never going to get cleaned out. It's going to read the same moisture all the time. The other thing too, check the wires for bare, shorted out wires. And the last thing is, hook up your display. Make sure it powers up and everything is good. That's what we need to do before harvest. And then during harvest, typically you want to back up your data. At least my advice, and this comes back from my old computer days, at least once a week. Some of the displays now, because we can connect to the cloud, you can do it daily or every time you shut it down. You want to back up your data. I can't stress that part enough to anyone. Data is so important, and keeping backups of it helps with some of that redundancy. So that's kind of the annual maintenance, and that's what we've all seen here so far has been for the typical combines that we see out there: the John Deere, the Case IH, New Hollands, Challengers. So yield monitors and other types of crops do exist, and so we'll kind of wrap up this unit a little bit looking at some of those. So cotton is one of those. Most of the newest cotton pickers that you see out there, kind of a representative example there. As the cotton comes into the head, it's a little bit of finger units are pulling that bowl off the plant, and it kind of separates it out, and then basically it's sucked up through the ducts up into the container, where then it's offloaded later. Well, they years ago have developed it's an infrared light emitter, and so it's emitting infrared and taking readings, and basically it's monitoring how much that cotton is coming up through that ductwork. And so you have one on each duct, and it's kind of hard to see here in this photo, but they are there on the back side. There's a little bit sticking up here on the front side towards the top on the middle there. But that is that's a cotton yield monitoring system. Another one that we see is forage. John Deere's several years ago came out with what was called the Harvest Lab, and there's kind of a picture there on the right hand side, the yellow colored one, and what this was is on a forage chopper. And basically it was a sensor, and it's stuck down into the discharge chute, so as the material's coming through the chopper and it's going out into the being offloaded onto a truck or a wagon, it's measuring the amount of it was measuring moisture and a few other things. There's another sensor on a chopper that will measure the tonnage. Just recently, John Deere came out with an updated model, what's called the Harvest Lab 3000, and you can see a picture there of it in the center, the green one. This is kind of a newer, updated one. What makes this one special is that you could stick it on the forage chopper, just like the other Harvest Lab that was, or you can take it off and plug a cable from your computer into it, and you can do some measurements right there. So as your silage comes off the pit and you want to feed it to cows, you can take measurements. And there you can see there's a list of measurements it can do. It can measure the moisture content, measures the dry matter. That's what the DM is there. Measures protein content, the starch, and then a couple of the detergent fibers, the neutral detergent fiber and the acid detergent fiber. Those are all key things in when you're feeding silage. It relates to how much of silage do we feed. So now there's a harvest lab that can measure that, so you can adjust your rations according to what the value of the silage is. So kind of unique. And that's all we really see in terms of yield monitors out there in terms of other crops. And so to kind of wrap up with a few of the other technologies kind of related to harvest, and we'll probably see a few of these creeping up in some future units. But one that's just been coming out here recently is John Deere has what's called their active fill. And this is on their forage choppers. And basically what there's a sensor at the end of the discharge chute. And what it's doing, it's actually painting a target where it's dumping into. So you can kind of see there in the picture. And this is what the operator sees in the cab. So it says, yep, here's the wagon. And it's actually taking measurements of how much is in the wagon. So the operator knows where do they need to move the chute. I think they're working on, if I read it right, they'll be working on to where the chute will automatically move. So as it's taking a measurement, as you can kind of see there as well, we need more silage in the back of that wagon. So it's automatically going to move that chute towards the back of the wagon. So this is kind of an interesting thing coming up as it relates kind of to the forage harvesting side of things. Some other things out there, we've really seen the whole vehicle-to-vehicle communication. So here's Case International came out with what's called vehicle-to-vehicle control. As you watch the video, as the guy is going through the combine, it's time to unload. So there's a tractor and a grain cart in the area. It's been notified, sends a message. Tractor operator replies, and once it gets close enough, the combine takes over control of the tractor. So right now that operator is not even steering the tractor. If you look at the video, you can kind of see that. So tractor and combine are basically communicating back and forth. So we don't have to worry about collisions, and we're making the best use of that tractor and combine. And it's a lot stressful. As a person who's run a tractor and a grain cart in the past, or the person in the combine, it's always as you're trying to combine, you're trying to make sure you're not going to overfill, making sure it's positioned just right. Here, this system takes that into account for you. So, something kind of interesting. Another one we've seen, kind of something similar, came to us from Kinsey a couple years ago, and this was kind of a shock. Kinsey developed an autonomous project. It's still going through development right now. But here we go. We have the tractor and the grain cart. Combine's going through the field, and when it's ready to unload, combine operator notifies the system. So the tractor and the grain cart power up, and basically they come out through the field. So yeah, combine operator signals the tractor grain cart, I'm ready to unload. Tractor and grain cart come up all by itself, no operator in the cab. And the reason this works so well is there's actually LiDAR sensors, so laser sensors all around that tractor, so it's looking for objects. If it detects objects or something that the tractor can't navigate around, through, or over, it will program it to stop, or take evasive action, whatever it needs to do. So Kinsey's still working on this. It's been in limited testing the last couple years, and yeah, once it's done, operator says I'm good to go, and tractor and grain cart take off and head back to the end of the field. So once again, something not really related to yield monitoring, but something we're going to start seeing more and more of, I think, in terms of automation. So kind of gives you a couple ideas, and you can kind of see where the future is going from here. But so with that kind of wraps up this unit in terms of the video lecture series. So if you head to Blackboard, you can finish out this unit with the assignments and activities that need to be accomplished. Thank you, and have a great day.